Look at trig identities, and we're going to talk about some strategies. So here's our question. Sine squared x times cos squared y minus cos squared x times sine squared y is equal to sine squared x minus sine squared y. Okay, this definitely kind of looks like a difference of squares. It's not a bad idea to try it out. We did it just before we started this, and we didn't really get anywhere. So instead, we took another strategy. We decided because the right side of the equation is only written in the function of sine, we were going to change everything on the left side of the equation to a function of sine. So we're going to change our cos squared y and our cos squared x so that we're dealing with sine instead. That way, maybe that's a route we'll take. So what were we able to replace cos squared y with?
1 minus sine?
Yeah, that's right. So we used Pythagorean's identity, right? So we'll write that in green. We had 1 minus sine squared, and we have to make sure the variable is the same. So they had a y, okay? Over here, we have subtract, and I'm going to put this kind of in brackets, okay? And the reason I'm going to do that is because this negative is technically being applied to both of these. So anything we do where we're changing this, we have to make sure at the very end that we're going to distribute that negative back in. Okay. So our cos squared x, what can we write that as?
1 minus sine x.
1 minus sine squared x. And then that's still times, I didn't leave myself a lot of room, sine squared y. Okay, so that bracket might be where we're having trouble before. So the next step, we're going to distribute. Okay, we're going to take that value and distribute to both of the values that are written in green. And same here. It doesn't matter which side we're multiplying by. You can still distribute from the front or the back or the left or the right. It doesn't technically matter. So sine squared x times 1 is just going to be sine squared x. And then sine squared x times sine squared y, because the variables aren't the same, it's not like we're going to end up with sine to the power of 4 of anything. Because they're not the same, we just write them beside each other. And because one's positive, one's negative, we're going to get subtract sine squared x sine squared y. Okay, and then I'm going to leave this negative here and our bracket. So we're going to do the distributing over here, and we'll distribute that negative after. So sine squared y times 1 will become sine squared y. Okay, subtract, and same idea again. Because the variables are different, we can't really write them, we can't simplify it, so we're just going to write sine squared y times sine squared x. Okay, so there's still one more step here. Because this is negative, or think of it like it's a -1, we need to distribute that -1 to both of the terms that are in here before we can start to simplify. So everything outside stays the same, sine squared x minus sine squared x times sine squared y. -1 times sine squared y will become negative sine squared y. And then because -1 times this negative makes this positive, so we get positive sine squared y times sine squared x. So we have like terms now. This guy here and this guy here, maybe we should just highlight them. Okay, so we have minus sine squared x times sine squared y, and we have plus sine squared y times sine squared x.
Oh, so they cancel?
They cancel. And though they're written in a different order, there's a rule in multiplication. It's called the associative property. It means no matter what order something is in multiplying, it doesn't make any difference. And we can test this theory. Say I didn't remember that, but I wanted to test it. What is 5 times 2?
10.
10? What is 2 times 5?
10.
Did it change the answer? No. So it doesn't matter what order we put things in. It's when multiplying, it's the exact same. So now that we've tested that theory, we know that these are the exact same. And because one's a negative, or think of it like coefficient -1, coefficient +1, they eliminate. They technically create a 0 or cancel out, whatever you want to call it. And that means we're only left with sine squared x subtract sine squared y, and that's exactly what we started with on the right side.